This is part A, second example under the title binomial distribution. The problem is in 256 sets of 8 tosses of a coin, in how many sets one may expect heads and tails in equal numbers. Let us consider the 8 tosses of a coin. That is the uh, binomial distribution here. Later we will discuss about this 256 sets because we are just consider one set first, finding out the probability value. Then final stage we can multiply that with 256 sets, we will get the final answer. So now comparing the details with the binomial distribution, here n is 8 and 8 tosses, a coin tossing is the experiment, and sample spaces are basically head and tail. Respective probability values 1 by 2, 1 by 2 never change at any trial. Therefore, this is binomial distribution, and here x is the binomial random variable and it takes 0 to 8 possible values. We have to find the probability value of equal number of heads and tails. Now, if we toss 8 times a single coin, 8 tails we may obtain, or 1 head and 7 tails, 2 heads, 6 tails, then 3 heads, 5 tails, or 4 heads and 4 tails, that is what we required, 5 heads and 3 tails, 6 heads, 2 tails, 7 heads, 1 tail, and all 8 heads. These are the possibilities of that tossing process of a single coin 8 times. 4 head, 4 tail. That is the target of this problem. Now consider again the problem. Here experiment is coin tossing, sample space H and T, number of trials is n is 8, and probability values are respectively 1 by 2, 1 by 2. Probability of 4 heads and 4 tails is the target. If we consider x as the random variable and taking event as getting head, then p of 4 heads and 4 tails can be written as p of x equal to 4, because if x denotes the number of heads, then automatically 4 heads means the remaining 4 will be tails. Therefore, p of x equal to 4 is the calculation portion. As per binomial distribution probability mass function formula, NCR, p power r, q power n minus r, we can enter all those values 8c4, 1 by 2 power 4, 1 by 2 power 4. Because here n is 8, number of trials, 4 is getting 4 hits, and 1 by 2, 1 by 2 are respectively success and failure probabilities. The respective powers are here 4 and 8 minus 4. So both the powers are 4. Simplification gives 70 by 256. The actual question is, out of 256 sets, we have to find how many sets equal number of heads and tails we occur. Here 70 by 256 is the entry which represents in one set this portion 70 by 256 portion of getting chances for getting equal heads and tails. So for 256 sets, we have to just multiply this 2. That is 256 into 70 by 256. So cancelling 256, we get 70. Actually, the meaning is out of 256 sets, the number of sets with equal heads and tails is 70 sets. Actually, we are calculating the probability value for one set. That is, 8 times tossing a single coin is considered as one set. The probability of getting equal heads and tails is 70 by 256 for single set. But out of this process is repeated for 256 times, they are treated as 256 sets. So out of this 256 sets, 70 sets may be the result of getting chances for getting equal number of heads and tails.